Hello, everyone. Hello, everyone. The title that was announced in the leaflet was WaterEnergy Nexus only. And this attracted so many questions once the workshop started. Everybody was asking me, what WaterEnergy Nexus and what do you do? And what do you mean by WaterEnergy Nexus? Is it a technology? Is it some kind of method? And I agree, WaterEnergy Nexus as it on its own is a very vague term, and it's a very broad term. So I decided to give you more specification in my presentation title. So what I've been working on is to provide solutions for secure and sustainable power generation in a water-scarce land such as Saudi Arabia. WaterEnergy Nexus is a concept, is a vision, is a perspective. It's not a technology, and it's not a method that you could apply. You could think about it, and why do we have to think this way? If we want to think about the future, if we want to think about mitigating carbon footprint, if we want to think about reducing water footprint, we need to think about the interrelationship and the interdependence between water and energy, because they're the most valuable and important resources that we have. So this will summarize the agenda that I will be, on the topics that I will be covering during my presentation. I will first give you an overview about how WaterEnergy Nexus how water and energy are connected as main resources. So if we look at this image, and we follow the blue arrow reflects the water flow, and the red arrow reflects the energy flow. So this is one way to look at how we use energy for water. We use energy when we treat wasted water or wastewater. We use energy for our homes, for our offices, for our everyday use, for our gadgets, and we use water to produce energy. So we rely on water to produce energy. So this shows the interconnectivity and the interdependence between water and energy. To summarize the pictures that I've just shown you, I want to tell you brief points or where we use water for energy and where we use energy for water. So we use water for energy when we use water to generate electricity, to fracture oil and gas from the underground, and for renewable. Some of renewable technologies also rely on water. And then we use energy for pumping the water from the ground. We use water for treating water or desalinate water. And we use water for heating and cooling, for energy for heating and cooling, and for delivering the water. So this shows the interdependency between the two main sources. This is a map that shows the water-scarce areas around the world. And looking at Saudi Arabia, it's very clear that we are a very scarce, water-scarce place or water-scarce land around the globe. The level of scarcity is even extremely high, and it's over 80%. So how are we going to produce our energy while being one of the most water-scarce lands in the world? Here I will talk about WaterEnergy Nexus in the US versus Saudi Arabia, because I came across this very interesting document from the Department of Energy explaining the WaterEnergy Nexus here, and it was very inspiring me to carry further work in this area. So this is, I apologize about the top, but it's about an estimated water energy flow diagram, a Sankey diagram, that shows how water and energy flow together and how they're used in the US and USA. So we talk here about the energy resources and how they are flowing to transportation, different energy resources, biomass, natural gas, coal, nuclear, geothermal, and hydro, and wind, how they're flowing into the different applications, residential, commercial, industrial, and so on. And then we have the water sources. We have the fresh water, saline water, and fresh ground and saline ground, and how they're also distributed to different applications. I was very inspired by this diagram, and I wanted to create something similar to Saudi Arabia. However, it was a big challenge because we don't have data to do that. So we spend a lot of time looking for data, collecting data, and second-hand data, and we came up with something similar or on the same lines. Now I agree because I'm using second-hand data that might not be the most accurate plot that show the figures or the correlation between water and energy in Saudi Arabia, but at least it gives you an idea of how water and energy are interconnected. So we have the main sources of energy are petroleum and natural gas. We have 30%, around 30% of petroleum is going into power generation, and the remaining amount is going into transportation. We have 30% of the other source of energy of natural gas, and it's going into power generation. And these are the sectors or the areas where it can be distributed: residential, commercial, and desalination. In terms of water resources, we have seawater that's used in huge amounts compared, for example, to the USA, the saline water. Because we are a water-scarce land, this makes sense. And this is the groundwater that goes mainly to agriculture. So we can see that was very surprising to us to see how much amount of water is going to our agriculture. This is something I want to look at in a few minutes. And then we have small amounts of treated wastewater. We have a surface water also, and it's going into consumed and ocean discharge. These are where they are distributed. So that's the previous diagram reflects the current state. But in the future, we'll have increasing population. The population will increase, and then we'll have increase in power demand. So how are we going to produce more energy to fulfill the increased demand? With the current projection from now until 2030, we have thermal power generation is the most dominant one, in addition to a bit of renewable solars and solar thermal and nuclear. However, if we look at this plot, we can see that from now until 2040, with the current policy, if it hasn't changed, the production of energy will not be able to cover the demand. This means that we have to look into more sustainable resources in order to produce more energy to fulfill the demand. So in order to do that, we need some tools to help us quantify the amount of water that we need in order to produce more energy. And there are several models that I've discussed in a talk I gave to my group 2 weeks ago, but I'm not going to go through them because they're going to take some time. I will discuss the one that we initially wanted to use to apply it for the water and energy situation in Saudi Arabia, but due to the absence of data that I couldn't get a hold of, I wasn't able to apply it. But I can explain it to you in quick terms. So this model is focusing on 2 cooling systems. In Saudi Arabia, we mainly use 3 cooling systems, but this model measures the amount of water used in 2 cooling systems. The main cooling systems are once-through cooling and recirculating cooling, or evaporative cooling. The recirculating cooling takes the water and use it to cool the heat that is generated, and the water is evaporated into the atmosphere. Whereas the once-through cooling take the water in using its current temperature and then use it to cool the heat that is generated and then reject the water again to the ocean or to the water reservoir that it was used from. The third cooling system that is used in Saudi Arabia, it's dry cooling system. But this model, the one that we wanted to apply, focus on measuring the amount of water that is used in recirculating cooling and once-through cooling. The water here is called consumed because it's evaporating, it's not coming back. Whereas the water here is called withdrawn because it's picked up and then thrown back and withdrawn back in the ocean. However, the temperature here when the water withdrawn will be much higher than before when it was extracted, and this will affect the ecological life in the sea and would pollute the water. So this is one of the downside of once-through cooling. In addition to that, we ran some, I'll talk about the calculation later. This was the main idea of the model, to produce some input data of the cooling system, the heat loss and the heat rate, and then to produce the water consumption value and the water withdrawal value. That was the main idea of the model that we wanted to apply. We ran a simple calculation comparing between a cooling system in Jeddah and a cooling system in Boston, giving the water temperature in Jeddah that's 10 degrees centigrade and the water temperature in Boston. I think I swapped the two titles, so Jeddah should be here. I was so surprised. How come? Well, I wish actually, but that's not the case. So Jeddah should be here and Boston should be here. I apologize for the typo. So what we found out is when we use once-through cooling, in Jeddah we need to use 4 times more the amount of water to cool the water, because the water temperature is quite high, so we need to use about 4 times of the water. When we use the evaporative cooling or the cooling tower, we need to use about 3% additional water. So this means, in the conditions and the circumstances and the weather conditions in Saudi Arabia, we need to use once-through cooling seems to be more efficient. And here, this is a comparison between the 3 types of cooling, and in terms of their water withdrawal, water consumption, plant efficiency, and capital cost. And although dry cooling doesn't rely on water completely, but it's very high. It's very high. The capital cost is quite high, and it's not very efficient. So the once-through cooling, compared to the wet cooling towers or the evaporative cooling, shows that perhaps the evaporative cooling is the most suitable type of cooling for power plants in Saudi Arabia. And now we'll talk about the future, using renewable energy to look into the WaterEnergy Nexus. And if you notice, I added the word food, because it's very difficult to not add it into the equation. So in the future, we will have increase in the population, and the demand will increase for more energy, more water, more food, due to 3 main factors: climate change, the heat waves that are coming, and the urbanization and the population growth and the globalization. So it's not only Saudi Arabia that's facing these challenges, it's the whole world, and we all need to think of sustainable way to produce all the needed resources, which is water, food, and energy. And this will also focus on the interdependence, because to produce energy, we need water. To produce food, we need water and energy, between the 3. When we think about renewable energy and how can we use it for the future, we think about what others are we up to producing renewable energy, and what is the type of renewable energy that is much more suitable for Saudi Arabia, given the conditions that we have and given the water scarcity issue. So we are one of the countries that are signed up for renewable energies, and this shows that it is expected by 2030, if we use renewable energies, we'll reduce 20% of water among the Gulf countries. Given the solar map, we can see, or we can predict, that Saudi Arabia is one of the most suitable lands for using solar energy. So I'm going to focus here on solar energy, only how can we use it to facilitate the future production of energy, or the demand. Right. I talked to you earlier about the models that I discussed earlier, that covers the water, energy, and food, or integrate the need for water, energy, and food nexus. But all of the models that I've covered earlier, looking into efficient ways to produce more water and more energy and more food. However, we have a challenge of waste. And I was always inspired of looking for ways to integrate the waste management. So here I found a paper that was recently published this year, February this year, that's proposing a very conceptual model. It's on a very conceptual level that deals with waste. Because whether we have an increase in demand for water, energy, or food or not, there will always be a waste that we need to deal with efficiently. And Saudi Arabia is considered one of the highest food consumption, and we need so much data, interestingly, about Saudi Arabia and food waste, and we need to reduce our waste at least by 30%. Of course, the food waste issue in Saudi Arabia can have many, as in any other countries, and as in many other countries, can have many social factors contributing to it, but this doesn't neglect the fact that we have waste that we have to deal with in order to deal with the whole problem. So what I'm proposing, the model that I found, or that it's proposed in the paper, is looking at dealing with the food waste and the energy waste and the water waste as inputs to produce new sources. So for example, it deals here with the water waste and then use it as a material resourcing. It deals with the food waste to produce bioenergy and biogas and biodiesel. It deals with all types of waste to use it as an input into others. So it's an integrative model dealing with waste management. And it appeals to me, and I'm looking forward to explore this more in the future. So as a closing remarks for my presentation, as much it is important, as I said in the beginning, to think about ways to mitigate carbon production for our countries and for the future world, it is also important to reduce water footprint, especially if we are a water-scarce country. And that was the main, or the take-home message. I would like, at the end of my presentation, to thank Professor Ghanem for letting me be his protege, the Center for Clean Water and Clean Energy, Professor Lienhard and Professor Tommy, Kate, Teresa, and Hayden, who are great, and Saudi Aramco, Effet University, Dr. Haifa Jamal for her great support and trust in me to nominate me for this fellowship. And I have a great support network that helped me to go through and gain as much knowledge as I am. So to be honest with you, if I tell you that it was an easy ride, I wouldn't be telling the truth. I came from a different background, which is an information system background, and I knew nothing about water and energy. But when I came here, I had to learn so much, and I couldn't do it without the great support network that I have. Dr. David Warzinger from the RK lab, and then Dr. Santosh Shambhu from my lab, and he sits next to me, so he's very lucky. Dr. Catherine Ong, and she was the only female also in my lab, so it was a sigh of relief to see her there. And my wonderful RGD lab mates, and thank you for being here. Thank you. That's it. Conclude my presentation.
Thank you. Thank you very much. Very interesting topic.
Thank you.
I'm sure there are some questions.
Maybe there is no time. Okay.
So you talked a little bit about water scarcity, and I'm curious, can you explain more about groundwater versus seawater and how you can use them in power plants and what's the difference?
Right. So groundwater is the water that's available in the ground, and the seawater. I think it wouldn't be very efficient to use seawater for desalinated water, because we will use it. We will put much more energy to convert it to fresh water and use it for example, for agriculture. So I think groundwater, since it's already available, and it would also need treatment before we drink it, I think it would be more efficient to use it for agriculture rather than for drinking, and use the desalinated water as fresh water for drinking. I don't know if this answers the question.
Right. Well, and also, can you use seawater for your power plant cooling, or do you need to use?
Oh, okay. Yes. I mean, this is a debatable issue. Given the power plants and the cooling systems, some people think that a paper by Dr. Sharqawi and Professor Lienhard about the issues of the seawater properties when it's used in cooling power plants. And it is very interesting. I mean, it can be used, but there are issues that has to be in manufacturing issues that I'm not covering really up to this date, but it has to be taken into account when using seawater for cooling towers. But for once-through cooling systems, I think we can use the seawater as it is without desalinating it, and it won't cause the problems for the power plant. However, for the environment, it will, because it will pollute the reservoir, the water reservoir, and it will pollute, affect the life of the whatever the reservoir. Yes.
It was a very nice talk that you gave.
Thank you.
I mean, the main problem maybe is in our countries, developing countries, energy saving and water saving. So are you taking into account in your study also this matter, that how you can convince the people, or how you can do this, that people should save energy as well as recycle the water or wastewater treatment? and save the water also.
It's a huge part of it is a social issue. I agree, but I think we have to convince them, and we have to tell them that if we have a very scarce amount of water, and we're facing the future with all the increasing demands to fulfill or to have sufficient production, we have to think of practical ways. Otherwise, just not using waste because it's waste. It's not very practical. We need practical solutions, and we need to raise the awareness. I know it's hard work, but it's important to start from perhaps the policy makers and the decision makers. If they're convinced, then perhaps we can make more effort for the public.
My follow-up question is that can you also send these recommendations to the decision makers also in the kingdom?
I think the purpose of this work is to convince the decision makers that we need, to think about other solutions. Yes.
Thank you very much.
Thank you, sir.
Interesting work.
Thank you, sir.
And very useful, I hope, in the future. But are you interacting with the Abdulatif Jamil lab for food and water?
I'm very interested in the lab. I attend almost all of their events, but I haven't had interaction yet.
So this actually leads to a question I was going to ask, which was in relation to data needs that you might have. We have, through the Jamil Lab, had contact with SWCC, for example. We may be able to help you acquire data you need. We have also had contact with the food ministries in Saudi Arabia.
Thank you very much. That would be great help, because finding data was quite a big challenge. I mean, me and my wonderful friends, we spent so much time looking for data everywhere, and all what we could find is secondhand data. Thank you. And I've made contacts, but it will be better if it's going to be through food center. Thank you.
Well, thank you very much.
Thank you, Sam.